Okay, programmatic drivers. So programmatic drivers, what you're seeing here is a risk classification for NASA payloads. It's intended for assigning a risk classification to projects and programs. It establishes baseline criteria that enable users to define the risk classification level for NASA payloads on human or non-human rated launch systems or carrier vehicles. It's also a starting point for understanding and defining criteria for tailoring. The general philosophy is that the simpler, less complex projects should require much less documentation and fewer formal reviews. Project products should be sensibly scaled. The criteria for determining the type of mission is given in this left column. So let's just go through it. So a description of the types of missions. We are probably closest to the smaller science or technology missions, which includes ISS payloads. When it comes to criteria of priority and acceptable risk level, we're lower priority and higher risk. For national significance, we're of medium to low. For complexity, we are medium to low. I would say low is probably where we reside because we're also on the very low end of the spectrum when it comes to cost or budget. I don't think we even make a blip in NASA's overall budget. Our mission lifetime is less than 2 years, it's short. We have few to none launch constraints. In fact, we don't impart any launch constraints on the launch providers. They impose it on us. Our alternative research opportunities or reflight opportunities are many. There are a lot of opportunities for us to fly. It's just a matter of booking one. And then the achievement of mission success criteria, medium or significant risk of not achieving mission success is permitted. Minimal assurance standards are permitted, and that's associated with our high risk profile. And then here are some examples that are, I would say, even larger than the types of missions that we're flying. So these are better known and have more money associated with them. But still, in a NASA world, this is probably the closest we're going to get to our own classification. So the consequence of our classification dictates the definition of these characteristics. It's going to define the size of our team, which is really small, the amount of media that we'll get, the acceptable risk level that we're designing to, the complexity, the mission lifetime, the budget, flight opportunities, and mission success criteria. As to this question, projects that are very similar, you would think that the classification would be the same. The change that the most defining characteristic of a mission that could change that classification is risk. Although the criteria space is rather large, so I foresee many opportunities to be different. Something that I referenced in the textbook that I didn't expand upon are the NASA procedural requirements, which is the acronym NPR. So I apologize, I will include that in the next revision of the textbook. So the definition of a NASA procedural requirement is that it establishes the program and the project management requirements by which NASA formulates and executes research and technology programs and projects. It applies to, down here you'll see a screenshot of the applicability section. NPRs are applicable to NASA headquarters and NASA centers. And this includes the Jet Propulsion Lab, which is an FFRDC, federally funded research and development center. Because we are applying for a NASA CSLI launch, it's best that we also adhere to this procedural requirement. So we just reviewed, we are a Type D mission. And for Type D missions, these are the example project technical products that we either have to be fully compliant for, so we need to follow that standard, or we can tailor to our needs. So because we're a smaller, higher risk project, you'll see that there's a lot more documentation that we can tailor to our need because we're a less complex project. So the amount of documentation should scale with that complexity. And what does tailoring mean? Tailoring often comes in 3 areas, like eliminating a requirement that does not apply to the specific program or project, eliminating a requirement that is overly burdensome. For example, when the cost of implementing the requirement adds more risk to the project by diverting resources from the risk of not complying with the requirement, or scaling the requirement in a manner that better balances the cost of implementation and the project risk. Let's see. So to this question, is it fair to say that we call NPR requirements, but we really evaluate each mission individually? So yes, if you're a type D, that can be the case. There are certain documentation that you have to adhere to, but as we just saw, there is a lot that you can subjectively decide whether you want to go full force. If you were a type A, B, or C, you'll see that the requirements are much more stringent and you have to be fully compliant with all of this kind of documentation. Okay. Another driver are the different processes involved in implementation. So there are nuances associated with these processes, which are separated into design and reviews and development. So there can be logistics built into either of these processes that improve or provide obstacles in your program. In the design phase, there are tools that lead to higher productivity or better quality designs. For example, we'll be getting a systems toolkit tutorial from Dr. Miguel Nunes today, where we can plot an orbit, show the ground track of a satellite, which is important for Earth observing satellites and for ground station tracking. And we can extract the intensity of the sun during an orbital profile, which is important for power generation purposes. We used to have human computers, so people who would calculate orbits and approximate the amount of power that a satellite can generate over an orbit. But now we have SDK, which is a more precise software application that streamlines this whole process. In this course, we try to offer as many open source tools as possible, so there are minimal barriers in designing a spacecraft. So reviews are here to offer honest feedback on your ability to fulfill the mission design and stay on track with cost and budgets. Getting quality reviewers who know their stuff and are honest with you will lead to a quality design. And having reviews scheduled in a timeline or schedule can keep you accountable with your schedule and your budget. In the development process, sourcing materials and equipment can impact the quality of your design, your schedule, and your budget. Component availability for CubeSats is increasingly more accessible with commercial off-the-shelf components. Access to testing facilities can help you quickly iterate your hardware design, as there's not a lot of lag between sending your hardware, because there is not as much lag between sending your hardware out and communicating how to conduct tests offsite. And then finally, ITAR and EAR are US security policy constraints on defense or defense-related products that need extra paperwork, effort, and time. So to expand on that, ITAR and EAR stand for International Traffic in Arms and Export Administration Regulations. ITAR regulates the sale, distribution, and manufacturing of defense-related items. EAR regulates dual-use items not covered by ITAR, but still applies to some defense-related items. Each regulation is governed by a different governing agency with different rules. So for ITAR, the governing agency is the US Department of State, whereas EAR is more on the business side, so the Department of Commerce. And there are different documentation that you can refer to for classification of components regulation. The only component in our kit that falls under ITAR or EAR is the GPS unit, which was produced in Taiwan. So I'll tell you a little story about this because I think it illustrates how ITAR and EAR affects the development or the development process. Procuring the GPS took an entire summer and semester, which is tough for a fast-paced project. To work with the GPS unit specifically, we have to draft an International Memorandum of Understanding, or an MOU, when distributing these kits to ensure that the students who work with this particular product are US citizens. There are security reasons behind these regulations, like avoiding the passing of intellectual property, particularly of defense-related products or knowledge, to pass to hostile foreign nationals. So now to the questions. I thought that this question about the ISS being truly international was interesting. So I had to do a little bit of research, and it turns out that China is not allowed to be on the ISS. So since, here it is. Since 2011, the United States National Aeronautics and Space Administration has excluded the Chinese government and China-affiliated organizations from its activities, including using funds to host Chinese visitors at the NASA facilities. In 2010, Representative John Culberson urged President Barack Obama not to allow further contact between NASA and the Chinese National Space Administration. In a letter addressed to the president, he wrote, "I have grave concerns about the nature and goals of China's space program and strongly oppose any cooperation between NASA and CNSA's human spaceflight programs without congressional authorization." I can tell you a couple stories about that. The Chinese National Space Agency has pursued their own persistent structure in space, like the ISS. The reason why there's suspicion is because China's companies does, I guess, reverse engineer our technologies quite well. For space in particular, there was an incident in history where our Apollo modules seemed to be replicated by the Chinese Space Agency to the point where different standards and mounting structures looked eerily, suspiciously similar. And I think that's been a general thing. So this is my opinion. What I've noticed is that the Trump administration was cracking down upon that in their last 4 years. And I think that holds true when it comes to the aerospace sector as well. Does this mean getting technologies into third world countries are much more difficult because of these regulations? Getting technologies into third world countries, yes, I would say that is true. I think the US is a lot more protective than the other way around when we're adopting technologies from other countries. So for example, HSFL is working with South Africa and some Scandinavian countries. These companies that reside in countries that are not the US are providing CubeSat components. Now, I'm a little less eager to say that the US does that for other countries. I don't have experience with that. But I think it benefits us that we're US citizens and we're on this side of the fence when it comes to technology development.